Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another Leetcode problem, that is longest common subsequence. So it's a medium type question and it's a very popular question, as you can see from the likes. So given two strings text1 and text2, we have to return the length of the longest common subsequence. So let's see with an example what the problem is saying. To better understand the problem, that if suppose we are given with a b c d e and another string 1 and string 2 as a b c d f, the longest common subsequence, we have to find the longest common subsequence, will be a, that is common, b, that is common, c, that is common, d, that is common. So longest subsequence will be a b c d. Suppose we have a e c h g c h g c. What will be the longest common subsequence? We see that a does not match with anything, e does not match with anything, so the longest common subsequence will be c of length 1, and here it will be length 4. So pretty simple. Longest common subsequence we have to find. How we can approach this problem? So first way is to use the brute force, like recursively finding all the subsequences of string 1, all the subsequences of substring 1 and all the subsequences of string 2, and then check which all subsequences are matching and take the matching subsequences and take the longest out of it. Right, this will be our brute force. Now let's see some possibilities. So if I am given the to find the recurrence relation, let's see some possibilities, and for first possibility, let's see an example. Like if I am given a b e d and s2 as b c d. Now what can we see in these two strings? Like we will iterate, we will go from the right to left for both the strings and compare character by character. So we'll compare the first characters on the right for s1 and s2, and we saw on the right that it's d, so they are matching. So if character at index 1 is equal to character at index 2, what recurrence relation we can derive is 1 f of index 1 comma index 2 is 1 plus f of index 1 minus 1 comma index 2 minus 1. That is our first recurrence relation. Why 1? Because we are done with first character, we are done with d. Now we have to find the LCS for the rest of the substring apart from d, apart from the matched character. Now what can be the second possibility? So if I take the same example again here, so in the next step, when the first character matched, where we have to go, we go left, one character left, and we see the characters are not matching. So when the characters do not match, what can be the possibility? The f of index 1 and 2 will be the max of whatever the LCS for index minus 1 and keeping the index of string 2 as it is, or shifting the string index of string 2 and keeping the index of s1 as it is. Like, so there are two possibilities that can take. First is ed and s2 equal to bcd. So this is matched, so we can take the LCS of this and this by shifting 1 for s2, or we can take the LCS of this one and the complete, and keeping the index for s2 as it is. So either shifting the index of string 1 once, and or in reducing the string 2, we can see whether we are getting any matches further or not, right? Because we know these two characters are not matching. Maybe if I reduce s1 and keeping the s2 as it is, we may find the maximum, or we can reduce s2 and keep the s1 as it is, right? From the index where it was not matching, then we can find the maximum out of it, right? So these are the two possibilities that we can have. So let's see an example using these two recurrence relations, how we can derive our recursion tree. So if you see, I've taken gh and ge, right? So we will have f1 comma 1. The pointer will start from the last index, that is 1 comma 1. The pointer will be pointing here. E and H, the characters do not match. So once I can shrink the left part, and also I can try shrinking the right part. So here I have shrink the left part, that is I have removed H and kept G as it is, and GE for the right string, right? So this is S1, this is S2, and kept as it is. So I'll get 0 and 1, where 0 points to the index 1 of the string 1, and 1 points to the index of the string 2. Now if I again reduce, again the characters are not matching, so I have to reduce the I have to go with two options, either reducing the string 1 or either reducing the string 2. I will reduce string 1 here, so I will reach f minus 1. So the index of string 1 will go minus, and the index of the string 2 will be remaining as 1. And if I reduce string 2, I will get g and g, that f of 0 comma 0, the index of string 1, and index of string 2 will be 0 comma 0. Then again if I now they are same. So what happens when they are same? We have to do 1 plus the f of index minus 1 and index 2 minus 1. So f of minus 1 comma minus 1, this recurrence relation. So now here what will be the return for f minus 1 or minus 1? Because this is empty string, so there is no common subsequence, so it will return 0 if this is 0, and 0 plus 1 equal to 1. Because it is empty, f of negative, so negative will return 0, so it is 0 will return 0. From f 0 comma 0, it will return 1. It will return 1 because we went for not matching. Now it will take the maximum of the two, that will return 1. Now again here we will traverse the right part of it, that is when we'll reduce the s2 part of it. We worked for the reduction of s1, now we'll reduce s2. So f1 comma 1 will be reduced to f1 comma 0. Now f1 comma 0 will again go for f0 comma 0 and f minus 1 comma minus 1, because the characters were not matching. Then we were reducing the string 2, like this recurrence relation. Now here again the characters are not matching, because the index 1 is pointing to H and index 2 is pointing to G. They are not matching. So what we will do, we again reduce the string. By reducing the string, what we will have, we'll remove this H, we will point to G, and G will remain as it is. So we will f of 0 comma 0. So again f of 0 0, the characters are same, so what we do, plus 1, f of minus 1 comma minus 1, so that will return 0. So f1 is 0, 0 plus 1, that will return 1. It will return 1. F minus comma negative will return 0. What is the maximum of 1 plus 0? That is 1. What is the maximum of 1 plus 1? That is 1. So we have one common subsequence, longest common subsequence between GH and GE. We saw both the relations, recurrence relations coming into picture in this recurrence diagram. So I hope this is clear. Now let's see the time complexity of it. So time complexity of brute force will be 2 to power n into 2 to power m, because we are seeing all the subsequences. We are seeing all the subsequence of string 1 length of string 1, and all the subsequences of string 2. So string 1 is of length n and m, so what all subsequences I can create of string 1, that is 2 to power n, and for string 2 2 to power n, and total possibilities will be 2 to power n to 2 to power n. So can we reduce the time complexity? Now how can we reduce the time complexity? So as we can see, so what we do generally when we have a recurrence relation and the problems can be broken down into sub problems, so we will find we know that it is going to be a dynamic programming problem. And to solve the dynamic problem we use memoization and tabulation method. So in this video we'll see memoization technique. So what memoization aims at top to bottom, right? So let's see how we can memoize this approach, this recurrence relation, so that it is a so we can apply dynamic programming approach. F of 0 we are calculating here, f of 0 we have calculated here, right? So this is for f0 comma 0 we are again getting the call for f0 comma 0. So if we cache this sub problem, right, comma 0, the next time f0 comma 0 will arrive, will return from the cache instead of doing the recursions. So in this way we can use memoization, and the time complexity will be big O of n comma m, because for each m we will have maximum n iterations, because for each m, like for each character of string 1 we will match with each character of string 2. So each character of string 1 will be matched with each character of string 2. What will be the space complexity? Space complexity will be order of m into n plus order of m plus n, that will be of auxiliary space. This will be for the DP, for the cache, and this will be for the auxiliary space, that is stack, that we are maintaining for the recursion calls. So the maximum can be m plus n. Why m plus n? Because at a time in the stack the maximum can be either m or maximum can either n, because we are either at every level we are deleting either one character from S1 or one character from S2, right? So in one of the path we will have only one of the string present. So if you see this path, we have GE, the string 2 present in the stack maximum, the other one is removed. So at most we can have m or n, so that is why O m plus n. So let's see the code part for it. So we calculate our n and m, the length of the two strings, then we create our DP, that is a 2D array, because for each m and n we are doing the recursive calls, right? For each index 1 and index 2 we are doing the recursive calls. So what is the idea, what is the rule for declaring the DP? Take the inputs, see the input, what are the parameters we are taking apart from the strings, that is index 1 and index 2. So we have to take the DP of n into m. Now it will be n into, we initialize DP as n into m, and we initialize all the values to -1. Now we call our LCS with text 1, text 2, we'll start with the last characters, and this is the worst case. So whenever index 1 goes less than 0, negative, we return 0, and if that is present in the cache, we'll return from the cache. So there are two recursive resolutions that we talked about. If the text at index 1 is equal to the character at index 1 is equal to character of index 2, what we will do, we will do 1 plus LCS of index minus 1 and index minus 2, and else if the characters do not match, then we will have to take the maximum of LCS index minus 1 and LCS index 2 minus 1, right? If the characters do not match, then we have to take the LCS of index minus 1 and index 2 as it is, or LCS index 1 as it is, index 2 minus 1. So let's run this code. So yes, test cases are passing. So this solution is working fine. So hope you like this video. If you like this video, please share and subscribe. It will give me motivation to present in front of you guys videos like this. Thank you very much.